So the solution of a differential equation is when the function and its derivatives are substituted back in, the equation is satisfied. Right? Just like any kind of a solution, it makes the statement true. All right? So when you verify, here's what we did when we were using identities. You work from the one side to get the other side. Okay? So there will be more than one solution, but you don't have to worry about that. That's where that C comes in. When you're verifying, you don't have to worry, well, there's another one. We don't have to worry about that at all. Okay, so let's verify. This is the solution, is a solution. So that's my solution. And this is my DPQ. Okay, so we're going to put the solution in my DPQ. All right, so we're going to start dy dx minus 4y. Okay, equals. Finally, we should be at 0. That's the grand plan, right? Remember doing that in pre-calc? That chapter 7 was pretty heavy on that. Remember that? Yeah. Yes. Okay, because we did a lot of it.
Yes.
You good? Okay. All right, so we know that y will get replaced with 4x, okay? So y is going to be e to the 4x, okay? But dy dx, we're going to have to put it in there. All right, so we're going to have to figure it out. Dy dx, what is it? 4e to the 4x, that's right. Okay, you get the chain rule, e to the u. The derivative of u is 4, that's where that came from, e to the u. Okay, so that's going in right here, 4e to the 4x. Okay, so just when verifying the solution, work from one side, we're going to put the function and its derivative back in and see that, oh yeah, that definitely is going to equal 0. Okay, so I put dy dx in right there. Minus 4, I put y in the green. Okay, now 4e to the 4x minus 4e to the 4x is 0. I'm done way before I thought it was going to be. So I'm done. That's verification. Okay? You started with the most complex side, you ended with the least complex. Okay? I'm not going to be real intense here. Okay, what's the matter? All right, let's try a couple more verifications. Okay, let's verify that y equals that root 12 minus 4x squared is the solution of y times y prime plus 4x. So we're going to start with y prime plus 4x equals, oops, I don't want to write equals 0 yet. Okay, so I'm going to plug in y. What's y? 12 minus 4x squared, radical. Okay, y prime. Okay, so I'm going to have to figure out what y prime is. All right, that is, y is what? 12 minus 4x squared to the half. Or what's y prime? Pull the half around, decrease this by 1, and what's left? Negative 8x, right, derivative of the inside. Okay? That's like the power rule if you don't want to use the chain rule. It's technically the chain. You take the 1/2, pull it around, power rule, decrease it by 1, and then take the derivative of the inside. You can spend time and do the chain rule if you need to. Okay, so right beside it, we're going to write that. I can clean it up if I want, but otherwise I'm just going to write it like that. Oops, not like that though, am I? That would be down here, right? 12 minus 4x squared to the negative 1/2. Okay? We might have just gone ahead and done this too. instead of leaving that 1/2 on the 8. You'll do that eventually anyway. Okay? Plus 4x. All right, we want 0 when we're done. We can't just say, oh, that equals 0. You got to show what's going to happen here. This and this cancels. So what's this? Negative 4x plus 4x equals 0. Okay? They're so simple, they are sometimes confusing because there's not much to do. You just throw them in there. If you do the y prime wrong, that would be the only thing that would go wrong here at this point because they're just very simple. Okay? Anybody getting lost here? Nope. All right. Try this first by yourself. I'll give you a minute. What you're doing. Go ahead. Wait, which one are you going to start with? You have to start with one or the other. Okay, and write 2y plus x first. No. It's okay. It's moving on you, but you have to write either this exactly or this. Okay, now you can start plugging in. Good. Do the math. Distribute. Okay, we're going to do that.
Or Incas. We're doing 2 Incas.
Yeah. Okay. So she did 2y equals dy dx. There's the proof. 2 times y. I got substituted right here. There's y. She did the math right there. There's your plus x. Then we cancel. You get the negative 1/2, which she found to be dy dx. Okay? Yes?
Well, in the beginning, I just subtracted the 2y.
Nope. It's not okay. Why is that not okay, girls? Remember? So from here you did? Okay. Isn't that already assuming that that is true? If we're verifying, we can't do that. You can't manipulate something that you're trying to prove true.
So just find the
Yes. 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 And that's kind of like where you know you're going. And so, when she did it, that was really a good idea to put dy dx, because otherwise we wouldn't even know where we're going. But if you're going to start here, we know we're going to dy dx, which she found to be negative 1/2. Okay? You can't manipulate something that you're trying to show to be true. All right, very good. Okay. When solving differential equations, we are usually interested in finding a solution. Now, this should look familiar, okay? In physical problems, we will want a specific solution that satisfies a specific condition called an initial condition, and these problems will be called initial value problems. Okay. Find the solution. We're just going to go right to the example. Find the solution of the differential equation y prime equals 3x plus 2 that satisfies the initial condition y of 2 equals 1. Now, initial got its name because usually it's initially, here's where we started. This one doesn't happen to start at 0, it happens to start at 2, but that's okay. Initially, we do know that this is some kind of relationship between x and y. Okay, so what do you think we're going to do first to find the solution of this differential equation? Antiderivative. So you might want to do like y equals the antiderivative of y prime, just to kind of be clear about what we're doing. So we're going to find the antiderivative. Okay. That is 3x plus 10 dx. I probably should put dx here. Okay. And what is that? What's the antiderivative, Sophie?
3 halves x squared plus 12 plus 0.
Why didn't I write 10? Sorry. Thank you. That was my bad. Okay. And her voice dropped, but I didn't think she should have been done. Okay. Now, on the free responses, just so you know, you don't put plus C there and you end up, because of the initial value that you end up getting the right answer, they're done with you. They don't give you any more points if you don't put plus C. It's a really big deal. So don't forget your plus C. Okay, so that's y prime. Y equals, that's y rather. Now what do we do? Plug the initial value in. So y of 2 means 2 goes in for x. It's kind of weird notation. Okay, it's like f of, but now it's called y of. Same idea. 2 squared over 2 plus 12 times 2 plus c equals 1. Because that was the initial value, 2, 1. All right, so what does C equal? We got 6 plus 24 plus C equals 1. What's C? Negative 29. So y, the solution is y equals 3 halves x squared plus 12x minus 29. So that part you've solved for DDQ before. You just didn't call it that. Okay. That's the solution, yep. You're solving the differential equation. You're solving for a function that fits in there. Yeah, if we were to verify solution of y prime equals 3x plus 12. Okay, so if we wanted to really verify, because Mary Grace doesn't believe us, okay, when we verify, we check our answer, right? So y prime equals 3x plus 12. Y prime, what's the y prime here? For x plus 12. Okay, so y prime. Yeah, I don't even. Let's see. 3x plus 12 equals 3x plus 12. 3x plus 12 equals 3x plus 12, I guess we'd have to say. We'd start with this end. And then we'd say, oh, where's y prime? Here's y. So y prime is 3x plus 12 certainly does equal y prime. Kind of weird, but yeah. Okay? Yes, you're solving. Solving a DiffEq, you're finding y. All right, find the antiderivative. Plug in initial value. And solve for C and find the specific solution. Okay? Remember, there are lots of general solutions depending on what C would be, but once we have this initial value in there, there's just one solution. Okay? All right. For what values does the function, for what values of R does the function y equals e to the Rx satisfy the differential equation? 2y double prime plus y prime minus y equals 0. Okay, so any suggestions about what we could do here? Find y prime, okay. So what's y prime? R e to the Rx, okay. So we could put that in here, right? Okay. And we can find y double prime too, okay. R is just a constant, remember x is your function. Yep. Okay. Is everybody getting those chain rules just quickly like that? I know Mary Grace is. Yes? E to the u is, you're going to take the derivative of u, which is where you get that additional r. E to the u is the derivative of e to the u. Okay. So, plus 2y double prime r squared e to the rx. Okay, now, for what values of r? Don't forget what you're doing, because it looks like what? What is that? We're looking for r. You mean e to the rx? Yeah, I think that's a great idea, Jessica. And when we take that out, we're factoring it out. What's left? Okay. All right. Now, remember, when we have 0, okay, what? Is this not going to equal 0? No. Okay. So, right, e to the rx is going to 0. No, it's not. But 2r squared plus r minus 1 is equal to 0. Okay. So, we got a quadratic that equals 0. What do we try to do with it? Factor it. Okay, or we use the quadratic formula, but I think it should be factorable. I'm going to put a plus or minus here. Minus and then plus. Very good. So 2r equals 1r equals 1/2, or r equals -1. Those are the answers. Yep. Okay. So they're just kind of, they're going to ask you something in maybe a weird way, and again, maybe you're like, wow, what is that? But once you start taking it apart and doing what, you know, you just kind of think of something to do, and sometimes it works and sometimes it doesn't. So you just have to think of something else. All right. Back to a normal, find the solution of the diff EQ. Y prime equals 1/2 x squared minus 1. That satisfies the initial condition y of 0 equals 2. So this is just a normal differential equation problem. And we're done. You want to do it together, or you want to do it? Just do it. Okay. Oh, shoot. Come on. Freeze. Okay, what do we get? Abby, what did you get?
X cubed over 6 minus x over 2 plus 2.
Anybody else? Is that what y'all got? Okay, so I'm gonna just, instead of working through it, I'm gonna verify it. Okay, y prime. I'm going to find y prime here. I'm going to pull that around. That's going to be 1/2 x squared minus 1/2. Okay, and then if I plug in a 0, I get 1/2, -1/2 instead of 2.
You're plugging into 1.
Oh, duh. Okay, yes. Okay. So typically we don't start with the answer, but so we would have done this. right? Which is 1/2 x squared minus 1/2. That 1/2, it gets distributed. And then you did what? X to the 3rd over 3, which is x cubed over 6. So far, so good. And then 1/2 x here and c, right? And then we plugged in a 0 and got 2. So 2 equals 0 minus 0 plus c. C is definitely 2. And then here's our answer. Okay. Okay. Which when you plug in, it works out the same way. Yeah, yeah. Yeah. We'll talk about that later when it comes up again. But anyway, that's it. That's your homework right here. Don't do number 4. It's crossed out. We're verifying. We're finding a general solution. We're finding a specific solution. Which of the following are functions? It's a kind of a multiple choice, but there may be more than one answer. And then you have also these match the DiffEQs with a solution graph. These are solution graphs which DiffEQ matches which. I didn't give you any hints. Okay? That was not on there. All right, you remember this thing I gave you that you must know cold? Oh, yeah. Okay, on the back side of that was the format of the test. Just FYI, this problem that you did right here, this was number 4. You saw 4s across the top. This was number 4, and it said number 4 here. Number 4 should have been no calculator. Okay, and it says it on there. Yes. Okay. There's 2 problems, 1 and 2. And if you're looking at old tests, they've changed that. So it used to be like 3 and 3, but now 1 and 2 use calculator. 4, 5, 3, 4, 5, and 6 do not. Okay, so I'm going to give you number 2 today. So that means use a calculator or not? Yes, so you can use a calculator back and front. Don't forget that the front part is all continuation. It would be like on 2 pages on your test booklet. Okay, it may be pages like this. And you don't get to write any more than the space provided. Okay, so don't be writing all over there because they're only going to write what's in the box. No, we're going to do our I'm feeling really kind. Am I? Does everybody have one? There was no kindness in geometry, let me just say that. I had to teach y'all a lesson. See, she's never done it before. I don't know. Because now if I give one to Mary Grace, then everybody that forgets one from now on out will say, well, you gave one to Mary Grace. I think you're just going to have to do it without. But I did the trig test without, right? Shut one. Mercy. Still running.